A very warm welcome, children. We are in the next part of our lesson is matter around us pure. The next topic is separation of mixtures. Many of the materials around us are mixtures. These mixtures have two or more than two substances mixed with them. We have many techniques as methods to be used for separating a mixture depending upon the nature of its constituents. Different mixtures are separated by using a different physical process. The various physical processes which are commonly used to separate constituents of mixtures are sublimation, magnetic separation, solvents, filtration, centrifugation, evaporation, crystallization, chromatography, fractional distillation, and separating funnel. In few cases, more than one of these processes are used for separating mixtures. In order to learn separation of mixtures, we can follow the three cases. First one, mixture of two solids, mixture of a solid and a liquid, mixture of two liquids. Now, let us discuss in detail by each one. Separation of mixtures of two solids. By mixtures containing two solid substances can be separated by following methods: by using a suitable solvent, by the process of sublimation, by using a magnet. Let us see now separation of a substance by suitable solvent. In few cases, one of the constituent of a mixture is soluble in particular liquid. When you see a mixture of sugar and sand can be separated by using water as the solvent. This will become more clear to form the following discussion. You can see sugar can be dissolved in water, whereas sand cannot be dissolved in water. This is how you can separate water to separate sugar and the sand. Whereas sugar gets dissolved in the water and sand gets down of the water. The second technique to separate a mixture of sugar and sand. Sugar is soluble in water, whereas sand is insoluble in water. This difference of solubilities of sugar and sand in water is used to separate them. With the help of a filter paper, you can separate sand from sugar. Common salt is also soluble in water, whereas sand is insoluble in water. To separate such type of mixtures, we can use water and filter paper as separation technique. To separate a mixture of sulfur and sand. Sulfur is a amorphous powder, yellow in color, whereas sand is not. Sulfur is insoluble in water and sand also is insoluble in water. So water cannot be used as a solvent to separate their mixtures. However, sulfur is soluble in carbon disulfide where sand is insoluble in carbon disulfide. So using carbon disulfide as a solvent, you can separate sulfur and sand. Second type of technique is separation by sublimation. We have already studied the process of sublimation in the previous chapter by changing a solid directly into vapors on heating and vapors into solid and on cooling is called sublimation. That is, from solid the substances enter directly into gas and gases enter into solids without entering into liquid state. We call this as sublimation. Few examples of the substances which sublime are ammonium chloride, iodine, camphor, naphthalene, anthracene. Whereas we can see an activity. How can you separate a mixture of common salt and ammonium chloride? Children, this is an important activity. You can see in the textbook. Ammonium chloride sublimes on heating, whereas common salt does not sublime on heating. We can separate ammonium chloride from a mixture of common salt and ammonium chloride by the process of sublimation. Now, take a china dish. In that, Please put some ammonium chloride and common salt and close the china dish with the help of a glass funnel inverted on it and put a cotton plug on it as shown in the textbook. And you just heat the wire gas with the help of a Bunsen burner. After some time, slowly the vapors of ammonium chloride get sublimated on the walls of the funnel, whereas the sodium chloride mixture is left off. And this is how pure ammonium chloride collected inner sides of the funnel get sublimated and can be separated from sodium chloride. The next technique is separation of magnet. Children, this game we have played many times in our childhood. Many times we take the magnet into a paper and try to put it in the sand. It attracts all the iron particles. This is how you can just attract iron fillings, whereas iron fillings are attracted by the magnet. This is also one separation technique. Next one, separation of scrap iron using electromagnetic, that is, when you apply electrical force on the magnet, it becomes electromagnet. It attracts the waste materials using electromagnet. Next topic, we have come to the separation of mixtures of a solid using a liquid. Few of them are separation by filtration. You can see a mixture of chalk and water is separated by filtration. By using filter paper, you can separate clear liquid from chalk powder. You all know about strainers, no children? We make it to use, we use it to make coffee and tea. These are the different techniques which can be filtrated. In the childhood, we have studied about the three-pot method as decantation. And last but very important, supply of drinking water in our city. You can say it follows many of the processes. In cities, drinking water is supplied from waterworks. In waterworks, the methods like sedimentation, decantation, loading, filtration, chlorination are used to remove undesirable materials from water. The source of water supply in the city is either nearby river or a lake called reservoir. The water from the lake usually contain suspended solid substances and some germs. Before this water can be supplied to homes, it must be purified to remove suspended impurities as well as germs. This can be supplied to homes. It must be purified to remove suspended impurities as well as germs. It is done at a place called waterworks. This waterworks of a city is usually situated near the bank of a river or a lake. The purification of river water is done by following steps. First step is the sedimentation tank. The water from the river or lake is pumped by pumping station into a large reservoir called sedimentation tank. This water is allowed to stand in the sedimentation tank for some time. During this time, many of the insoluble substances present in the water settle down at the bottom. From the sedimentation tank, water is sent to the loading tank. In the loading tank, some alum, we call it as patika in Teluguma, which we use in the front of our houses, and in the olden times it is used as an antibacterial, as a pumice stone, where you get cuts or boils while making a shave. The heavy particles of dissolved alum deposit in the suspended clay particles in water. Nowadays in Rajasthan, still in sandy areas, they use this. In this way, suspended clay particles in water get loaded with alum particles, become heavy and settle down at the bottom of the tank. The process of loading removes the suspended clay particles from water. The water is then passed through the filtration tank. The filtration tank has three layers. Fine layer of the topsoil, coarse sand layer, in the middle gravel with the tiny stones at the bottom layer. You have studied in the 8th standard, children, this one. The layers of sand and gravel acts as filters. When water passes through the layer of the sand, gravel, even the small suspended particles and other particles in the water get removed. The clear water is then passed into the chlorination tank. Children, in chlorination tank, they use bleaching powder. In bleaching powder, chlorine has the activity to kill germs present in it. This is called disinfecting of water or sterilization of water. The water now becomes fit for drinking. The clean and disinfected water is then pumped by the pumping station into high storage tanks. From high storage tank, water is supplied to homes and factories in the entire city through a network of big and small pipes. Separation by centrifugation. If we have a mixture of fine suspended particles in a liquid, we can separate it by filtration. This is how centrifugation is a method used for separating cream from buttermilk, and also it is used for suspending particles of a substance from a liquid in which mixture is rotated at a high speed. This is how our blood tests are performed for the plasma and the liquid. We call it as centrifugator. Separation of milk from cream. In milk, it is a suspension of tiny droplets of oil or butter in watery liquid. The process of centrifugation is used in dairies to separate cream from milk. The milk is put in a closed container and our mother churns with the centrifuger. This is how the butter evaporates. The butter floats on the topper layers, and this is how evaporation, crystallization, chromatography and distillation are the different methods of separation. Next one is separation by evaporation. Evaporation is used to separate a solid substance that has been dissolved in water. The use of process of evaporation for separating a mixture is based on the fact that liquids evaporize easily whereas solids do not evaporize. Let us perform an activity. You can see an ink solution in a china dish. When you just evaporate it for some time, all the water behind it gets evaporated and finally a mixture of ink solid remains. This is the process of separating by evaporation. Also, we have purification by crystallization. The process of cooling a hot concentrated solution of a substance contains to obtain crystals is called crystallization. Let us see how we can perform an activity. Impure copper sulfate can be purified by the method of crystallization. Take 10 grams of impure copper sulfate and dissolve it in minimum amount of water in a china dish to make copper sulfate solution. Filter the copper sulfate to remove the insoluble impurities as shown in the figure and heat it for some time on water bath. You can see after some time all the impurities get evaporated, whereas the pure blue colored hot saturated solution of copper sulfate is cooled slowly. This is how the impurities are evaporated and the pure substances form crystals. The last one, separation by chromatography. Chroma means color, graphy means technique. Chromatography is a technique of separating two or more dissolved solids which are present in the solution with a very small quantities. This can be performed by paper chromatography. The separation is based on the fact that two or more substances are soluble in same solvent, say water, but their solubilities may be different. To separate dyes in the different colors, for example, a black ink contains separate colors. In order to separate these substances, let us perform an activity with the help of a paper chromatography. Take a thin and a long strip of filter paper. Draw the pencil line on it as shown in the figure. About 3 centimeters, one from one end. Put a small drop of the black ink on the line. After some time, just put it with a pencil line. When the drop of ink has dried out, the filter paper strip is lowered into the tall glass jar containing some water in the lower part. Here we are using water as the solvent. The water gradually rises up and the filter paper strip by capillary action. Capillary means a very thin action, children, like how plants take up the water. You can see different colors are obtained at different distances. The chromatogram obtained by using black ink in the experiment has showed 3 colored parts on it. That means chromatography is an important tool in which black ink experiment has 3 colored spots on it. The applications of chromatography are, they are used to separate the solution of colored substances such as dyes and pigments present in the plant substances. Also, it is used to differentiate different children. It is used for differentiating genes in mother, father and children. How to identify the parents of the children. Chromatography technique is also used to take out these. Chromatography is used to separate small substances in the chemical reactions. Next one we have separation by distillation. You can see to separate salt water mixture, especially in order to get good drinking water, we can use this. We have an experiment. A mixture of common salt can be separated by the process of distillation. All that we need is a distillation apparatus. Please see in the diagram, children. Salt and water mixture is taken in the round bottom flask. When you heat it with the help of a Bunsen burner, slowly you can see the temperature has to be noted down, which is connected to a water condenser. That means one side inlet of water will be there, one side outlet of water will be there. From one side you can see pure water is coming into the beaker and the salt remains in the round bottom flask. This is how using distillation you can separate salt from water. That means we can make out drinking water from seawater. The last one is fractional distillation and separating funnel. Fractional distillation is also same like distillation, but with the help of different fractions of temperature you can separate these. This fractional distillation is the process used for separating two miscible, that means two dissolvable liquids by distillation to distillate in the collected fractions of boiling points at two different temperatures. That is very important, children. This one also. How to separate a mixture of alcohol and water? Alcohol or ethanol and water are miscible liquids. That means if alcohol is mixed with water, it cannot be separated so easily. Then how can we identify it? At 78 degrees temperature, alcohol starts to get evaporated, whereas the boiling point of water is 100 degrees. So using this fractional distillation, you can separate alcohol and water at two different temperatures. At 78 degrees you can separate alcohol, whereas 100 degrees you can separate drinking water. Let us see the activity how to do the fractional distillation experiment. The mixture of alcohol and water are heated in a distillation flask fitted with a fractionating column. Fractionating column means at a different temperatures they are collected, on which top a thermometer is introduced. When you get 78 degrees, you can see the alcohol comes out. Here also water condenser is fitted. Water condenser means it just controls the temperature by inflow and outlet of water. At 78 degrees temperature, you can collect alcohol. At 100 degrees centigrade, the water will be left over. This is how you can separate water from alcohol using fractional distillation technique. Next one, applications of fractional distillation. Fractional distillation is used to separate mixtures of miscible liquids like alcohol water mixture and acetone and water mixture. Here acetone and water mixture is used for cleaning our nails. Fractional distillation is used to separate crude oil, petrol into useful fractions such as kerosene, petrol and diesel. Fractional distillation is used to separate gases of the air. Separation of the gases of the air. This is the next technique. Air is a mixture of gases like nitrogen, oxygen, argon, carbon dioxide, helium, neon, krypton and xenon. The major component of the air is nitrogen. It is the second major component of air, whereas the other ones are present as very little amount. So, air is separated into component gases by following steps. Air is first filtered into removed dust, therefore the water vapor, carbon dioxide are removed. Then the vapor in the form of water vapor and carbon dioxide are not removed. They would become solid by cooling them. So this is how next air is compressed into a high pressure and then cooled. The cooled air is then allowed to expand quickly into a chamber through a jet. This expansion cools the air even more. The process of compression, cooling and rapid expansion of air is repeated again and again, making the air more and more cooler. Ultimately, the air gets so cooled and therefore it turns into a liquid. In this way, liquid air is obtained. Liquid nitrogen is liquefied by decreasing the temperature and increasing the pressure at the lowest boiling point -196 degrees. So warming on liquid nitrogen boils off and first to form nitrogen gas. The nitrogen gas is then collected from the top part of the fractional distillation column, as you can see. Liquid argon present in the liquid air has slightly higher boiling point of -186 degrees. So liquid argon boils off next and collected as argon gas in the boiling point. In the middle part of the fractional distillating column, liquid oxygen has a still higher point of -183 degrees centigrade. So the liquid oxygen boils off at the last and collected as the oxygen gas from the bottom of the fractional distillating column. You can see air is compressed. I am saying once again the process. Air is compressed. Therefore, on cooling and rapid expansion, it changes into liquid air, then allowed to warm up. Then nitrogen gets boiled first. Next, argon gets middle fractionating column boils second, and finally oxygen at -183 degrees centigrade. The last technique is separating funnel. Separating funnel is a tube-like structure which is closed at the two ends. I mean, we have one side for the inlet, one side for the outlet. You can see the diagram. You can separate a mixture of two immiscible, means which are not dissolvable liquids. Two immiscible liquids can be separated by using a separating funnel. That is, if you take a mixture of crude petroleum, when you shake it for a long time in the separating funnel, first heavier liquid like water comes out, later lighter liquid like kerosene comes out, and then that lighter substances such as white petrol, others all will be allowed out. Children, with this your lesson is over. I am sending the notes. Please copy the notes. Thank you. If you have any doubts, please put a comment.